A microprocessor is a computer processor that incorporates the functions of a central processing unit on a single integrated circuit, or at most a few integrated circuits. The microprocessor is a multi-purpose, clock-driven, register-based, digital integrated circuit that accepts binary data as input, processes it according to instructions stored in its memory, and provides results as output. Microprocessors contain both combinational logic and sequential digital logic. Microprocessors operate on numbers and symbols represented in the binary number system. The integration of a whole CPU onto a single chip or on a few chips greatly reduced the cost of processing power, increasing efficiency. Integrated circuit processors are produced in large numbers by highly automated processes, resulting in a low per-unit cost. Single-chip processors increase reliability because there are many fewer electrical connections that could fail. As microprocessor designs improve, the cost of manufacturing a chip generally stays the same according to Rock's law. The internal arrangement of a microprocessor varies depending on the age of the design and the intended purposes of the microprocessor. The complexity of an integrated circuit is bounded by physical limitations on the number of transistors that can be put onto one chip, the number of package terminations that can connect the processor to other parts of the system, the number of interconnections it is possible to make on the chip, and the heat that the chip can dissipate. Advancing technology makes more complex and powerful chips feasible to manufacture. A minimal hypothetical microprocessor might include only an arithmetic logic unit and a control logic section. The ALU performs operations such as addition, subtraction, and operations such as AND or OR. Each operation of the ALU sets one or more flags in the status register, which indicate the results of the last operation. The control logic retrieves instruction codes from memory and initiates the sequence of operations required for the ALU to carry out the instruction. A single operation code might affect many individual data paths, registers, and other elements of the processor. A microprocessor is a general-purpose system. Several specialized processing devices have followed from the technology. A digital signal processor is specialized for signal processing. Graphics processing units are processors designed primarily for real-time rendering of 3D images. They may be a fixed function or support programmable shaders. With the continuing rise of GPU, GPUs are evolving into increasingly general-purpose stream processors, while retaining hardware assist for rasterizing, but still differ from CPUs in that they are optimized for throughput over latency, and are not suitable for running application or OS code. Other specialized units exist for video processing and machine vision. Microcontrollers integrate a microprocessor with peripheral devices in embedded systems. These tend to have different trade-offs compared to CPUs. Systems on chip often integrate one or more microprocessor or microcontroller cores. Thousands of items that were traditionally not computer-related include microprocessors. These include large and small household appliances, cars, car keys, tools and test instruments, toys, light switches, dimmers, and electrical circuit breakers, smoke alarms, battery packs, and hi-fi audio, visual components. Such products as cellular telephones, DVD video system, and HDTV broadcast systems fundamentally require consumer devices with powerful, low-cost, microprocessors. Increasingly stringent pollution control standards effectively require automobile manufacturers to use microprocessor engine management systems to allow optimal control of emissions over the widely varying operating conditions of an automobile. Non-programmable controls would require the complex, bulky, or costly implementation to achieve the results possible with a microprocessor.